Hello friends, welcome to this video. In this video, we are going to see about Naive Bayes algorithm, which is one of the most popular and simple machine learning algorithm. Okay, let's go into the video and see the introduction of Naive Bayes algorithm. Naive Bayes algorithm is nothing but a classification algorithm that mainly based on Bayes theorem. We will go into detail about the Bayes theorem and the math behind it in the next slide. Okay, it also uses the concept of conditional probability. What do you mean by conditional probability? Conditional probability is nothing but a probability of one event occurring based on some relationship with one or more events. For example, let us consider a customer who has already bought a car and he has to buy some car accessories such as car seat covers and some alarming system to alert when there is a car theft. Okay, now we have the probability that the customer has bought a alarming system. What is the probability that he would buy a car seat cover in addition to buying an alarming system? We have to find this probability. That is, for example, let us consider the event A as the customer has already bought a alarming system. The event B is the probability that he would buy a car seat when he has bought a alarming system. So the conditional probability is nothing but P of B given A. This is the concept of conditional probability. And Naive Bayes algorithm uses or assumes that the features are independent of each other, that the features follow conditional independence between them. Okay, this is the basic about the Naive Bayes algorithm. Next we will see about the Bayes theorem. And this is the formula of Bayes theorem, that is P of A given B, that's equal to P of B given A into P of A divided by P of B. Okay, we don't understand nothing from this, right? Okay, I will tell you in detail that A is the classes that we need to predict and B is the features or predictors that we consider to predict the classes, and P of B given A is the likelihood that the feature B would occur given the class, and P of A is the prior probability of the class and P of B is the prior probability of the features or the predictors. So in this I have said that P of B given A is the prior probability of the class A given the predictors or the features of B, and P of A is the prior probability of the class and P of B given A is the likelihood and P of B is the prior probability of the predictor. This is the overview of Bayes theorem. In the next slide I will discuss the Bayes theorem with an example. Okay, let us consider one of the most famous data set that is used for Bayes theorem. That is, in this data set, we need to predict whether we can play golf or not based on the weather conditions that are prevailing outside. So, in this case, we have 4 features, that is outlook, and the feature outlook takes values as rainy, overcast, and sunny, and the next feature temperature takes 3 values, which is odd, cold, or mild, and the third feature humidity takes 2 values, which is high and normal, and windy takes a binary value or binary value, that is true or false, that is boolean value, that is true or false, and the class that we need to predict is whether we can play golf or not. So the classes that we need to predict is, in our case, there are 2 classes. One is that we can play golf, second one is we cannot play golf. This is the overview of the data set that we are going to use. So I will represent it using the formula. I have where here the y represent the 2 classes, that is we will play golf and we will not play golf, and x are the features, the 4 features we are considering. Okay, and I have represented the problem statement with the Bayes theorem. Okay, applying the Bayes theorem, and x are the features. In our case, we are considering 4 features. So x ranges from x1, x2, x3 and x4. Okay, then I will apply that That is, I will calculate the likelihood for each feature and I will multiply it. Okay, then in the denominator I have plotted the prior probability of the features. Each feature, each individual features I have find out the prior probability. Okay, next, since the denominator is common for both the classes, that is for both not to play golf and to play golf, it is common. So we can remove the denominator and we can introduce a proportionality constant, and also I have introduced a product of to product all the likelihoods of all the features given the class Y. Okay, and I have multiplied it with the prior probability of the class. Okay, which will give the probability of the class. Okay, in our case there are only two probabilities, but consider a case where there are more than two classes that we need to predict. So we need to consider the maximum probability of the class. So to find the maximum probability, I am introducing this argmax, which gives the maximum probability. That is the output of a classifier. Okay, I think you have a clear idea of the math behind it, math behind the Bayes theorem. Next, we will move on to the types of Naive Bayes classifier. What are the types of Naive Bayes classifier? Okay, scikit-learn, which is a popular Python library for machine learning algorithm, provides three types of Naive Bayes classifier. One is multinomial, next one is the Bernoulli, next one is the Gaussian. Multinomial is used mainly for text classification, where the use case is to find the frequency of the words. For example, instead of counting how many words are there, we need to count the frequency, that is the frequency of the words occurring in a sentence. In that case, the features are discrete. Okay, in that case the multinomial Naive Bayes classifier is used, and in the Bernoulli Naive Bayes classifier is used when the features are Boolean values. Okay, in our previous example we have saw about the golf data set. In that we have windy as a Boolean feature, that is yes or no. Like that, Bernoulli is mainly used for features that are Boolean or take binary values, either yes or no. Okay, for example, in text classification, whether the word occurs or not, like that, it's used for binary. Okay, binary features, Bernoulli. And the last and the final one is the Gaussian Naive Bayes classifier. Gaussian Naive Bayes classifier is used for features that takes continuous values. The features that takes continuous values and they are not discrete. In such a case, the values needs to be sampled using the Gaussian distribution. Okay, these are the types of Naive Bayes classifier which is available in scikit-learn Python library. Okay, now we will see the applications of Naive Bayes algorithm. Some of the applications of Naive Bayes algorithm are it is used in text classification. Next one, it is used in spam filtering. Next, it is used in sentiment analysis, etc. It is mainly used for the advantage is that it can be used for very large data sets and it is simple to use. But the major disadvantage of Naive Bayes classifier is that it assumes that features are independent, but in real-time scenarios, the features are not independent, they are dependent on each other. So this is one of the major disadvantages of Naive Bayes classifier. Okay, this is the full overview of Naive Bayes classifier, the math behind it and the use cases and their applications and the types of Naive Bayes classifier. I have tried to cover overall view of Naive Bayes classifier. So thanks for watching. If you like this video, like, share and subscribe to our channel. Thanks for watching.